Today is Thursday, April 9th, 2020. In today's lesson, we'll be exploring solving equations versus solving inequalities. In today's exploration activity, we'll be studying equations and inequalities. We're going to compare and contrast the procedures we use to solve them. Now, you'll remember, when we solve algebraic equations, we always begin by identifying the do. In other words, what's happening to the variable in my equation? And here, we can see the variable is being multiplied by 6. So my do is times 6. Now, to isolate my variable, to find the value of the variable itself, I need to use the undo, the inverse, the opposite, in this case of multiply by 6, which is divide by 6. And you can see here, we're dividing both sides of my equation by 6. In order to make sure that I consider the three big ideas of solving equations, right, I need to isolate the variable to find the value of only the variable. I need to use an inverse in order to do that. And I must maintain balance. To maintain balance means I must use the inverse on both sides of my equation. Whatever I do to one side, I must do to the other. When I use my undo, I find that the value of 1x, right? So 6x divided by 6 is 1x, or just x. X equals negative 3. When I graph my solution, on my number line, I place my value, negative 3, and a solid dot at that location tells me my solution is negative 3. Now, you'll remember, we always want to make sure we check our work. I should be able to substitute my solution in place of the variable in my original equation. So instead of 6x equals negative 18, I should now have 6 times negative 3, my solution, equals negative 18. 6 times 3 is 18. Different signs makes my solution negative. Negative 18 equals negative 18 is a true statement, and therefore my work checks. Now let's talk about solving inequalities. When solving inequalities, much of what happens remains the same. So let's see where things are the same and where things may be different. So we still begin with a do. What is being done to our variable? Well, here I still have 6x. The 6 is still multiplying the x. So my do here is times 6. When I use my undo, or my inverse, I find that I'm still using the opposite. I am still doing this to both sides of my inequality. I'm dividing by 6, the undo. When I do that, I find that 6x divided by 6 gives me 1x, or just x, and that in this case, x is greater than negative 3. In fact, the only thing I've seen that's different so far is over here, I have an inequality symbol of greater than, while over here, I have an equal sign. So far, those are the only things that I see are different. I have 6x, I have negative 18, I identify the do, I use the undo on both sides, and I come up with a solution. In this case, my solution is x is greater than negative 3. So when I graph, I identify the location of negative 3 on my number line, and then I stop for a moment. X is greater than negative 3. So can x be negative 3? No. It is all values greater than negative 3. So when the value on my number line is not included, I put an open circle. It says begin here, but don't include this. And every value greater than negative 3 would make my inequality true. In other words, every value greater than negative 3 is part of my solution set. In an inequality, I have many correct answers, not just one. We'll talk about that more in a moment. So earlier, when we were checking our work in our equation, right, we took the value from the number line and substituted in place of the variable. Well, here, what we have is an opportunity now to use any value, anything, anywhere on the number line, along that line, following this arrow, any of these values can be used in place of the variable. So I'm going to choose this one here, right? So if negative 3 is not included, then the next integer that is included would be right here at negative 2, right? Here would be negative 1, here would be 0, 1, 2, and so on. So we're going to use negative 2 and replace our variable with that value. 6 times negative 2 is negative 12. Negative 12 is greater than negative 18. Negative 12 is greater than negative 18. That's a true statement. Negative 12 is to the right of negative 18. It is less negative. It is nearer to 0. That means our solution is correct. So let's talk for a moment about these processes, where they are the same and where they are different. I think we would agree that one place where they are the same is using the do-undo, right? The do-undo process was exactly the same for equations and inequalities. Where they were different, well, where they were different was how they were graphed. In an equation, I have one solution, so I have one dot, a solid dot on my graph. That's it. But in my inequality, I had a line with an arrow, in this case going to the right for greater. I had many solutions in an inequality, whereas in an equation I had only one solution. Where they were the same was the manner in which I did my check. With my equation, I substituted the variable for my one solution. In my inequality, I still substituted in place of my variable, only now I could choose any solution from anywhere on the line. Notice I did not choose the value where the open circle was, because negative 3 was not included as part of my solution set. The do-undo is the same. The process for checking is the same. The manner in which my graph is set up is a little different, and the fact that I have many solutions in an inequality instead of just one solution in an equation would be something that's different. So here's another example. Again, we're still talking equations and inequalities, and our primary purpose is to compare and contrast. Where are the procedures the same and where are they different? In our equation, x minus 5 equals negative 2, again, we understand we're going to start with a do-undo, which means our do is minus 5, which makes our undo plus 5, which gives us a solution of x equals 3. On our graph, we place 3 with a solid dot. And when we run our check, we replace our variable of x with the value of 3. So that instead of x minus 5 equals negative 2, it's 3 minus 5 equals negative 2. And when we solve that, 3 minus 5 is negative 2. Negative 2 equals negative 2 is a true statement. And so we know our work is correct. So now when we solve an inequality, once again, we still start by identifying the do-undo. We see that in this inequality, x minus 5 is less than negative 2. We can see that our do is minus 5, which means our undo is plus 5. And we find that we get a solution of x is less than 3. When we graph that, we place 3 on the number line. It says x is less than 3. So first of all, we know that it doesn't include 3 because it doesn't say x is equal to 3. It says x is less than 3. So open circle at 3 since it's not included, and then left for less. Every single value less than 3 is part of our solution set. Every single value less than 3 would make this inequality true. And now we're going to check our work by testing that. In the check, we don't take our solution like in an equation, because in an equation there is only one solution. But we can take any solution from our inequality and check it. So if this is 3, then this would be 2, 1, 0, negative 1, negative 2, right? As we go left on the number line. I can use any of those values. So I'm going to use 2, this value right here. It's less than 3, it's on my line. So I'm going to take 2 and put it in place of my variable. So instead of x minus 5 is less than negative 2, I use 2. 2 minus 5 is less than negative 2. 2 minus 5 is negative 3, and negative 3 is less than negative 2. I come out with a true statement, which means my work is correct. Notice how many things are absolutely the same when I solve an equation and I solve an inequality. Things that stand out as being absolutely the same: identifying the do-undo. Things that stand out as being somewhat different: the manner in which they're graphed. My check is still done in the same way. The only difference is when I check an equation, I use the one solution. When I check an inequality, I can use any of the solutions from the line on my graph. Now that we've explored the similarities and differences between solving equations and inequalities, go back to Google Classroom and into today's lesson and complete the attached exit ticket.